Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems.
Hey, I'm Tom Gosi. This week on Hot and Cold, I've been waiting for this for so long. We're soliding up the building. We've got spray foam. This is going to be fun. You've got to not leave the TV. Get the food now during the commercial, and don't leave for the next half hour because we're going to have a lot of fun this week. We're here with Dave Lewis from Coastal Coatings. Dave, thank you for coming today.
Welcome. Thanks, Tom.
It's good to have you here. I have been, now, anybody who's watched the show knows that I love spray foam. And I've always used a little disposable spray foam systems, which are expensive. They're messy because I always get it all over. Matter of fact, I got pants with spray foam on it today, in your honor. And they're very limited. They don't give you a lot of capacity. We have a setup here where we have not a disposable system, we have a reusable, not even a reusable. You guys have the equipment in a truck. We'll show the truck in a few minutes.
Sure.
And you do this all the time. And just tell us about what's happening here.
Well, basically what we've got is we have a two-component system. It's an isocyanate or an A side or hardener, and a B side, which is a polyol and a resin. And what we do is we pressurize that material somewhere between 800 and 1,000 psi. Wow. Heat it up to about 125 degrees, send it down our 300 feet of hose, and it's an impingement mix at the tip of the gun. And that gun has a little mixing chamber that moves back and forth.
So it mixes right as it comes out of the gun?
Exactly, right at the tip. Exactly. The material is a closed cell polyurethane foam manufactured by BASF. The density is 1.8 pounds, which means that you spray a cubic foot, it weighs 1.8 pounds.
Right.
The material itself acts as its own vapor barrier. It's got the highest R value of anything going, roughly 7 per inch. Yep. And we can pretty much spray it anywhere. And we have sprayed in temperatures below freezing. We have very specialized foams that we can use in extreme conditions and as hot as 120, 130 degrees. Yeah.
Okay, so Dave, what I'm trying to accomplish here are two things. One, I want to save time, Tom, it's me, a lot of time in having to cut and fit in a really weird shape situation. Spray foam is absolutely perfect for this. But more importantly, I want to stiffen up this whole second floor area. And that's going to do it.
It'll work very well for that. Yeah. What we found is that spray foam gets into every nook and cranny. It's incredibly strong. Give you a basic idea of the strength of it. You can take a roof or a ceiling that has drywall on it. Yeah. 18 or 20 inches on center are your rafters. Yeah. We can spray 2 to 3 inches of foam on that, and I can personally walk anywhere on that ceiling and not go through it. The tremendous strength is one of the great benefits of this material over anything else. Yeah. And it gets in all these cracks and nooks, and it stops all the air movement from inside and outside of the house, which, as R value is very important, but stopping all that air movement is extremely important.
Right. And I understand that most manufactured housing folks now are using spray foam just to stiffen up the buildings for when they go down the road.
Exactly. That's one of the big benefits of an in-factory type application, where they can get the benefits of mass production and really cut the price down to where it's competitive with everything else. Yeah. And you get a very, very strong panel.
Okay. Well, we'll watch the guys do some more here and see how it all comes out.
Okay. Very good. Okay, what we're doing right now is Roger's coming back for his second and third passes. Generally on an application where we provide more than 4 inches of foam, we usually make it in 2 to 3 passes to get the full thickness. The foam kind of goes through some funny situations. It's very, very soft and fluffy for about the first 5 seconds. Then after that it goes through like a rubbery type stage for about 30 seconds to a minute and a half. And then after that, it starts developing its strength, and it will develop a little bit of a skin on the outer edge of the foam. Now, the foam is sensitive to ultraviolet light. As you notice right now, the color of the foam is basically a nice white, slightly yellow cover. After about 3 to 5 hours in the sun, you will notice that there is a significant difference. You can also see actually how it's rising. What we do after you sprayed that, and I should be able to kick it off, is right now it's in a very rubbery, kind of jelly type consistency. Very simple, very easy to rip. The overall cell structure and consistency is very good. So we just kind of keep an eye on this throughout the day. Now, if we throw it down, you'll see it bounce. Now, the other foam won't do that after it's gotten itself hardened up. So it's a big difference there. Roger's making his third pass, and then we're going to come back and make a final pass and go ahead and tie everything in from the top, and it should be all set from this side of the building. Okay, what we're going to do is show you a little bit about the equipment that we have at Coastal Coatings. When we come back into the trailer, we have a totally self-contained unit. In the front of the trailer is a 40 kW three-phase generator, which we built and wired into the entire truck. Over here we have our spray machine. It's the Gusmer H2035. It is a very high capacity, high pressure, high temperature spray rig. We use this not only to spray foam, but also spray truck bed liners and polyurea. On this side, what we have right here is our BASF A side, which is the hardener or the isocyanate. We have a transfer pump right here, and then on top, back over here on this side, we have the B side, which is the resin. All of this is also powered by our own internal air compressor. We have our own workbench with all the tools that we need, and we have plenty of lights. So we're a totally portable system that we can go anywhere in Maine and do just about any job that needs to be done. Now, as this material comes out, we have 300 feet of hose. The hose itself is essentially, it's got 4 basic parts to it. You've got your 2 parts, your A and your B, which are color-coded. You have your electrical section, which continues the hose heat, which maintains the temperature, which is set on the machine. You have the air for the gun, which is a gap gun or Gusmer air purge. And then you have what's called a temperature sending unit, and this is the hookup that tells the machine what the temperature of the hose is at the gun. So this is how all this material is maintained at proper temperature and process temperature throughout the entire equipment.
Well, Dave, you had pointed out to me how uniform the cell structure is on this foam. And that's something that's striking to me compared to the disposable systems I've used in the past. I've gotten weird mixing because you're at the mercy of 2 cans of pressurized chemical mixing properly at much lower pressures than you're running here. I'm sure that must make a big difference, is the pressure that this mixes in.
Exactly. The pressure, the heat of the material, the pressure, and the type of mixing. This is an impingement mix system.
Right.
And that overall will give you this uniform and consistent structure.
This is nice stuff.
And you can see how it's already, at this point, it's starting to stiffen up.
Yeah.
And we're about 5 minutes after we sprayed that.
As a foam aficionado, I'm very impressed with it. I love foam. Boy, that's something.
And something you notice too, if we take this piece here and let's say this big piece.
Yep.
Hard to break it, and it's getting very difficult.
After 5 minutes.
But you feel it's still warm. It's probably about 110 degrees right in this center section.
Yeah.
So that's what we got to only build it to a certain depth, and then from there we go ahead and do multiple passes.
Yeah.
So.
But it's he's doing good here. We're going to put have him shift over to the backside. I'm going to get some OSB up over that last area so he's got something to fill out to.
Okay.
And we'll be done in no time.
Yeah, we've probably got right now about 35 minutes into this project of spray time.
Yeah.
So
we got interrupted in the middle here. Central Maine Power came to hook up the electricity, which was a good thing. And although you're self-contained, you don't need electric power. You have your own generator and the whole
we're all set.
Match.
Yep, I got a 40 kW three-phase generator. Wow. It's actually got the capabilities of going to 60 kW. So if we have another ice storm, I'm going to be powering my neighborhood.
Yeah.
So
now,
it'll be all set that way.
Does this system run on 3-phase?
Yes, it is. It's a 3-phase system. Actually, the only thing that's really 3-phase on my pump is the actual motor itself. It's a hydraulically driven unit, and the motor itself is 3-phase. The individual heating systems, they're all single-phase.
Okay. So
I do have the capacity, if I so desire, to change the motor out and go to a single-phase unit.
And while we're talking about foam, oddly enough, there's other types of spray foams that are similar to these. The one that comes to mind is Icynene. You see it on this old house a lot. That's a very low density version, open cell.
Open cell difference. The main difference is here, and I'm also trained and certified to do both types of foam.
Yeah.
Icynene is probably the more popular one. I use Demolac. The biggest difference is with an open cell type structure, they use a different chemistry as far as a blowing agent is concerned. they use what's basically just water. Now from the water, that's how you get your cell structure, but what happens is the water has to escape as steam, and so it actually ruptures the cell wall itself. Everybody, I'm sure, has seen this. It's basically packaging material. The big difference is that you're going to find is that the R value is roughly half that of foam closed cell. It doesn't have the structural strength that this does have.
Right.
And it's a good product generally for more the mid-Atlantic regions and southern regions. But when you're talking Maine and Canada, the best thing to do is go with the closed cell foam.
Right. Right.
And there are other manufacturers. There's the closed cell foam. There is, well, you got BASF, which is one product I use a lot.
Yeah.
You also have Corbond, which we are also applicator of, and 3 or 4 different smaller blending houses that will sell you foam in a 55-gallon drum.
Okay. And really, for the cost benefit, I think you're way ahead using this material, the high-density closed cell foam.
You are. Let's say a typical 2x4 wall. This has a typical R value of 7 per inch. So on a 3.5-inch stud, we can, let's say, do 3 inches, get you an R21.
Right.
Now you take the other type, pink stuff, at best they advertise an 11. From there you take wind infiltration, the material not being set in properly, all that will add up to really about an 8 or 9.
Yeah.
So you're taking, let's say, a 9 versus a 21. It adds structural strength, stops air movement, so you basically got a situation of you pay now or pay later.
Yeah. And it's much more resistant to moisture, which is a significant
Exactly.
issue.
Yeah. Being a closed cell foam, it is not possible for water to get through here.
Yeah.
The National Air Barrier Association, which is now a big thing in Massachusetts and working its way from there, is using closed cell foam as one of their methods to put an air barrier in the house.
Okay. Tell you what, let's take a break here. We still got a lot more to talk about. We'll be right back.
I bet long to me. I want to make you go, honey, and I want to make you bunch a lot of good man. I want you to be the prettiest. I bet you're going to do my oh, should have been bad to me. I say, should have been bad to me.
Well, Dave, one thing we didn't talk about is blowing agents, and the fact also that people confuse, I get this question all the time, is this that foam that they sold in the 70s that's going to do all kinds of horrible things?
Sure.
And that's not the case at all.
No, not at all. That foam was actually urea formaldehyde.
Yeah.
And the formaldehyde was giving off basically a noxious gas that some people are just highly allergic to. The Canadian government did a massive cleanup of all of these homes up in Canada and have since become basically the world leaders in establishing criteria, standards, and practices with the foam. What we're using today is basically after 72 hours, you're not going to detect any emissions at all. The pieces that we shot this morning, you will not smell anything on them at all. So really we've gone a very long way in bringing this up to be basically a green product. Along that line, the blowing agents themselves, usually they started off with an R12 Freon, has since gone to what's called 141B, which is what we're using right now. And all these have a portion can deplete the ozone. And that's what the open cell people would sell as, you know, one of the benefits of their products. Well, from the Montreal Protocol of 1985, we have been instructed this year to switch over our blowing agents to what's called 245FA, which is another type of a material used for making the foam expand, but it has zero depletion of the ozone, or zero potential. So this is great, basically a 100% environmentally friendly product. And it has made it, it's more expensive. We're seeing a 25% increase in the cost of this material, but actually overall it is going to be the best for everything.
But the, just to put it in perspective, the Freon, the R12, R22s that were used years ago, those had persistence, or they lasted in the environment for years, literally tens of years. The materials that has been used up to this point is what, 30 days, 60 days? It's not a long period of time. It's persistence in the environment.
No, they don't last that long. Exactly. They do break down. The nice thing also is this material is 100% recyclable. So they can take this out, and there is a process for recycling this type of material.
Okay.
So there's benefits there.
Yeah. So if you look at it and you think, well, it's a petrochemical product, yes it is, but it's a very economical petrochemical product in that you're not burning this to make heat, you're using it to stop losing heat. And that's one of the things we're really going for here. I don't know how how the guys even feel, but I know they're kind of impressed with the R value we're going for on the structure, but the goal is that we want to show the investment versus what this house will do. And the goal here, I don't know if I shared it with you, Dave, is that this house will not freeze. That's where we're going. I don't know if we're going to get there, but in an environment like Maine, in the wintertime, with the kind of R values we're going here, which is about R60, some areas plus, an R60 shell, we will not have a freeze problem. In other words, we can walk away from this house and have no heat running and never have it go below, say, 35 degrees Fahrenheit. I suspect it'll be warmer than that, but we'll see.
That's usually what works out. When I do this project, the benefits to the customers are going to be at the end of the month, you look at your bill. There's absolutely nothing else in your house you can do other than the spray foam and, of course, board foam all put together where you can cut your heating bills upwards of half or greater. So people will buy double pane low E glass windows because they're energy efficient. But really, when you look at the bottom line, what's the best thing that you can do for your house? It's the foam. And the foam is really going to make the big difference.
Okay, well, we're going to keep watching the guys do their thing. And before we know it, we're going to be done.
Almost halfway done.
Well, Dave, this is turning out to be an incredibly easy project. Great project for me, because I'm just watching them do the work. Thank you for that.
Thank you.
We want to, you guys do more than just spray foam insulation, though.
Yes, we do. Our company also does what's called armor coatings or armor liners, which is what we're becoming known as right now. We're the only heated high-pressure spray-on truck bed liner in Maine. Pretty much anybody in Hogan Road or throughout the surrounding areas, you just ask for a spray-on bed liner and you can get one of ours. We've done over 5,000 pickup bed liners.
Wow.
And we've been in business just about 6 years.
Yeah, and those are rugged liners too.
Very strong.
And they look good.
Some of the other things we've done, Cascade Park, we provided a polyurea liner for the pond at the bottom, and probably more publicly would be the Children's Museum in Bangor. All of those figurines that have been cut and placed inside was basically spray foam that they carved, we top coated it, and then they painted it.
Okay.
So those are some of the higher visibility things that we've done.
So, and the pond liner, like at Cascade Park, that's a spray?
That's a spray polyurea product,
okay.
Yes. Yeah, they've had a severe problem with leaking. It's gunite type material. It's been sprayed
spray
twice.
Concrete.
It's cracking all the time. Basically, to sell that project, what we did is take a paver, spray it with basically truck bed material, hit it with a sledgehammer, smash the concrete underneath, but it was still very flexible, and all the concrete stayed there. So we've got an extremely flexible liner that can take the abuse.
So if somebody out there, because this is Maine after all, somebody out there has a fountain on their property, or even a gun-eyed pool that is disintegrating,
we've done it.
Give Dave a call. And we'll have Dave's number at the end of the show. Also, you're in every phone book just about in the state of Maine?
Just about, yes.
So Coastal Coatings in Brewer,
Coastal
Sparks
Coatings,
Avenue.
Sparks Avenue,
And we'll have the number at the end of the show. Dave, thank you very much.
Tom, thank you for the opportunity.
This is going to be, this is going to make the building.
Thanks.
Thank you.
Production support for Hot and Cold is brought to you by American Solar Technics, manufacturers of components for wood burning and solar heating systems.